and wondered if there's anyone else out there? A different type of creature living on another planet, just waiting to be introduced to a different species. How come we've never stumbled upon other life than we are in our galaxy? And more interestingly, if we aren't alone in the universe, it's curious that no one has ever tried to get into contact with us. The Fermi paradox aims to answer many of these questions. Hey, let's be honest, they've puzzled scientists, philosophers, and the general population for decades. It's named after the Italian physicist Enrico Fermi, who first proposed it in 1950. Given that the universe is vast and there's a pretty good chance other planets exist that could potentially harbor life, it seems quite normal to assume that there must be other intelligent civilizations out there somewhere. However, despite humanity's best efforts, we have not yet detected any real evidence of life outside of our planet. Apart from people we've sent into outer space on purpose, of course. This lack of evidence has made people wonder if we really are truly alone in the universe. More so, if there's another, more sinister reason for why we have not yet found any aliens. Now, one possible theory suggested is that we simply have not looked long or hard enough. The universe is immense, and other civilizations could likely exist on planets that are too far away for us to detect. The technology we would need to identify these civilizations is probably not even invented yet, or even if it is, it's surely not powerful enough to reach across light years of space. Could it be that we are the only intelligent life in the universe? This theory suggests that the conditions necessary for life to evolve and thrive are very rare. Like in our case, for example, the fact that our Earth has water, a stable atmosphere, a magnetic field, and a pretty reasonable climate. Some scientists can't help but think that ours is the only planet in the universe that has managed to produce these conditions, and because of that, also have intelligent beings wandering around its surface. However, this theory does not fully explain the paradox, as it does not account for the fact that the universe is so vast and has been around for so long, way longer than we have. The age of the universe is estimated to be around 13.8 billion years old, while our planet is only about 4.5 billion years old, give or take a few million. The more plausible suggestion is that there are other intelligent civilizations out there, but they are simply too far away for us to detect. This theory suggests that these civilizations may be located on planets that are much farther away from us than we can currently detect, or that they may be located in different galaxies entirely. Well, sorry to break it to you, but the universe is also expanding, which means that things aren't staying put. Even if we had the technical capabilities to start traveling between planets and galaxies, they might simply be moving away from us at a speed we'd never manage to catch up to. Just like all the previous ones, this theory has some flaws. That's because it does not fully explain why we have not yet detected any evidence of these civilizations. If they're far away, we're surely not able to detect them. But why aren't they trying to get in touch with us? It's hard to imagine that all of the other civilizations that may be chilling in our universe as we speak are less evolved than us. Looking back on a planetary scale, humans are really young. If we imagine that our planet is just 1 year old, then humans popped up on its surface during the final 20 minutes on December 31st. Compared to the whole existence of the entire universe, we're simply a blip. The final theory is that there are other intelligent civilizations out there, but they're simply too technologically advanced for us to detect. This idea indicates that these creatures are light years ahead of us in terms of science and development. They may already have technologies that are far beyond what we're capable of, and they are supposedly using these technologies to stay hidden from us. Sadly, this theory is somewhat more plausible, though it does mean that no other civilization wants to be friends with us and come out and play in outer space. Well, it does explain why we have not yet detected any real evidence of life outside our planet. But it does suggest another, more sinister fact. It raises the question of why these civilizations would choose to stay hidden, and what their motivations might be. Sadly, the Fermi paradox remains an open question, and scientists and philosophers continue to debate the possible explanations for why we have not yet found any friends to play with in the universe. Only time will tell whether or not we'll be able to solve this mystery. There's still a lot we have to accomplish when it comes to space exploration. In the future, space travel will continue to be mostly carried out by scientific and commercial robotic missions. However, the idea of your everyday human traveling to space will likely remain a dream for a long time. That's because of the high costs and dangers of injury associated with the process. Launching a single person into space currently requires a significant amount of energy, and the journey exposes individuals to extreme radiation and high speeds within a field of debris. Certainly, there have been attempts by rich people to make space travel more accessible, but it's still out of reach for most people. A single seat for a ride on a Soyuz capsule costs over $20 million. Some scientists believe we should invest more time and effort into space travel. But if you think about it, there's really no other place like Earth for us nearby. We can't breathe outside of our atmosphere, and there's no space object in our solar system that can support life as we know it. Take Mars, for instance. Even if we managed to travel there eventually, by the time we reach the red planet, we would have already spent months living in microgravity. That also means it would take us a lot of time to physically recover before they could start exploring this planet. After years of research, NASA figured out that living in microgravity conditions heavily affects the human body. It means loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upwards. This can lead to pressure on the eyes and even affect our vision. Now, just because we can't confirm there's life outside of our planet doesn't mean we didn't have some pieces of evidence throughout the years. Like in 2001, for example, when NASA researchers suggested an interesting theory about Jupiter's moon Europa. They mentioned that frozen bits of bacteria may be the cause of Europa's red tinge and its mysterious infrared signal, while magnesium salts were previously thought to be responsible for the infrared reflections. Data from bacteria living right here on our planet that thrive in extreme conditions fits the data just as well. These bacteria also have red and brown coloring, which could explain the reddish appearance of Europa. While it is unlikely that bacteria could survive on Europa's surface due to the extremely cold temperatures and lack of atmosphere, it is possible that they could survive in the warmer liquid interior and be released through geological activity. Going back to 1977, when a strange signal from outer space was picked up by a radio telescope at Ohio State University. The signal lasted for 37 seconds and was so strange that the person who saw it wrote "Wow" on the printout. The signal was very different from the usual signals that come from space. Sure, it could have come from a huge event in space, but it could also have come from intelligent creatures living in the universe that had a very strong transmitter. To this day, no one knows for sure what caused it.
Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
Watch the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids. entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices, because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
Let's see now. Mobile phones, remote surgery, communication satellites. You think it's just another science show on TV. But wait, the image on the screen is black and white. A middle-aged man wearing glasses is talking. It's a BBC documentary from 1964. The man's name is Arthur C. Clarke. Yep, that's the guy who helped Kubrick make the movie 2001: A Space Odyssey. You up the volume and can't believe your own ears. Clarke is describing our present as if he were right next to you. So, what exactly is he saying? The world in which we can instantly contact each other. This is a no-brainer. Clarke was talking about messaging apps. He spoke about how we would be able to contact our friends anywhere on Earth. And the best part is, we wouldn't have to know where they were. Yup, that sounds a lot like using a smartphone. Mr. Clarke, you won't even have to know your friend's number. The device will remember it for you. The phones in the 1960s weren't that advanced. This was the time when manufacturers were just starting to move from rotary dial phones to push-button ones. But Clarke saw further in the future of communication. He told a tale of how a person would be able to conduct business from Haiti or Bali as if they were in London. It was a BBC show, so don't be surprised he mentions the English capital. Anyone who's ever Zoomed or Skyped knows what the man was talking about. Digital nomads were hard to imagine 60 years ago. There was no other way to earn money but to have a 9-to-5 job. Today, you can open your laptop and work from anywhere on the planet. Next up, brain surgeons in Edinburgh operating on patients in New Zealand. Those were Clarke's exact words. He was right about this as well. Remote surgery became very real in 2001. A doctor who was in New York operated on a patient in France. How, you may ask? Robotics is the short answer. Did you ever have one of those remote control toys? The basic principle is the same. A surgeon controls a robotic arm performing the surgery. For this, they don't have to be present in the operating room. They can even be on another continent. Clarke was spot on with this prediction. Don't commute, communicate. Sounds like an advertising slogan, right? Close enough. This is another example of how Clarke saw it all. Recently, workers across the globe got used to remote work. Now they're simply refusing to return to the office. The least they'll accept is hybrid work. That's where you work from your bed for 4 days and then drop by the office one day to say hello. This would have been impossible in the 60s. I mean, you could stay at home, but then you wouldn't get paid. And this is not the end of Clarke's predictions that came true. He was a pioneer in predicting the future. In 1945, he wrote an essay called Wireless World. A great title if we take into account that the first Wi-Fi network appeared in 1997. But what was this essay about? Nothing much. just about launching communication satellites into orbit. But wait a second, that was more than a decade before the first artificial satellite started orbiting the Earth. Wow, impressive. Okay, but it's not like Arthur C. Clarke predicted the invention of the internet or something. Well, he did. In 1974, he described a device called console that every home would have. No, he wasn't talking about a gaming console. This console would have a TV screen and a typewriter keyboard, and people would get information from it. Isn't this a desktop computer? Of course it is, but explained in the 70s terms. Clarke could have also added the mouse as well. I mean, he got everything else right. He also predicted what this console/PC would be used for: getting bank statements, booking theater tickets, and browsing the news. This is exactly what we use computers and smartphones for today. And how do we do it? Google search. Arthur Clarke had a vision of what a search engine would look like. Is there anything this man couldn't predict? Well, he believed cities would completely disappear, but they are only getting bigger. The World Bank estimates that nearly 56% of the world's population lives in cities today. This figure will only increase in the future. Sorry, Mr. Clarke, that was a complete miss. Then there are borderline cases. The man spoke about a replicator. Sounds like a gadget from a Bugs Bunny cartoon. That's because it is. A machine that creates instant copies of everything is a bit off the charts. But, to be honest, we have 3D printers today, although they're not as sophisticated as Clarke's replicator. But who knows? This prophecy may come true in a decade or two. The British writer wasn't the only daydreamer of the period. Walter Cronkite, America's favorite TV anchor, also had a go at predicting the future. Just 3 years after Clarke's show aired on the BBC, Cronkite hosted a show called The 21st Century. The goal? To show viewers what a 21st century home would look like. And he was strangely good at it. Let's start with his vision of the living room. Full-color, big 3D television screen? Check. Console controls that operate various gadgets? Check. Music that plays from speakers at a push of a button? Check. Now, I could be wrong, but did Cronkite just describe a home entertainment system? I think so. Hungry for more? Step into the imaginary kitchen from the year 2001. The plates are made from plastic on the spot. Okay, that one was a bit off, but you can still buy disposable plates at the supermarket. That was not the case in the 60s. Also, you had to clean the house yourself back then, or hire help. Well, Cronkite and his guests hoped this would change. They spoke of small-scale robots that would accept instructions. They could even be programmed not to bump into humans while cleaning the home. And finally, these tiny robots wouldn't have to look anything like us. You're probably staring at the robot vacuum cleaner in the corner right now. Now let's talk business. The show imagined the home office with a futuristic printer. It would receive data from satellites and print our newspaper. Sounds naive enough today, but keep in mind that the first laser printer appeared half a decade after the show aired. There was also talk of a closed-circuit camera system. These intercom systems are in every home today. 60 years ago, you had to use a peephole to see who was at the door. But the most mysterious gadget Cronkite mentions is an electronic correspondence machine. They didn't explain its functions on the show, but it's possible they were referring to a smartphone. At the time, the TV remote controller was all but perfect, so this gadget seemed even more impressive. Okay, we all know what you've been waiting for. Flying cars, right? Yes, Cronkite included this prediction in his other show, this time about the 20th century. Every now and then there's news of a tech startup constructing a flying car, but it turns out to be a bust every single time. We can still only dream about taking off and flying over traffic jam. The show from the 60s got some things about cars right, though. Inflated pillows? They were probably referring to airbags, but misspoke. Cronkite also predicted anti-lock brakes. Manufacturers started installing these into cars decades later. Then there was cruise control and motion sensors. Tracking the distance to the car in front of you seems common today. In the 1960s, however, drivers could only dream about such a function. How many times have you heard your grandparents say how everything was of better quality back in their time? Well, this isn't always a good thing. Traffic signs were solid, so a car would be severely damaged if it hit them. Cronkite accurately predicted that modern road signs would be intentionally weakened to fail and save the driver's life. So you're driving down the highway, and an 18-wheel tractor-trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! Well, it's the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor-trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122, that's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It's estimated that the Andromeda Galaxy contains 1 trillion stars, compared with the Milky Way's estimated 300 to 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter, when the great square of Pegasus the Winged Horse is overhead. Draw a line across the great square diagonally upwards from the lower corner star, then go a little further beyond the square. There it is, but you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon, because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are. And this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving towards us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So, if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren's sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after the Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, the blue shift, a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, or red shift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble spacecraft is named, published his spectroscopic study of 46 galaxies, the light from all but one of which was redshifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue-shifted, moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 miles per hour seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, we need to determine the distance between them. And for that, we need, boom, supernovas. Type 1a supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1a supernova shines, its absolute magnitude. A Type 1a supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away from us. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, well, we get an approximate distance of 2.5 million light-years. Since 1 light-year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light-years away, even though it is approaching at the speed of about 250,000 miles, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor-trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Omega has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars were being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there's no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy might have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the Sun will have increased brightness on its way to becoming a red giant star. And humans will have already found another galaxy to inhabit. Happy traveling, dear humans! Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Ring-a-ding-ding. The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's-eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is.
Have you ever asked yourself, what is consciousness? If so, I've got some good news for you. Scientists seem to have begun unraveling this mystery that has been puzzling humanity for ages. Consciousness is literally everything you experience. The tune playing in your head for days on end, the bitterness of your morning coffee, the annoying pain of a headache, and the love you feel for your parents. But the origin and nature of these emotions and experiences, also known as qualia, they have been a mystery since people first started dwelling on this question. Some scientists believe that qualia don't exist or can never be studied by science. In other words, it means that we don't have feelings or sensations at all. They all exist just in our mind. But most scholars accept consciousness as a given. They try to figure out its relationship to the objective world described by science by setting philosophical discussion aside and looking for the physical footprints of consciousness. Like, what is that highly excitable piece of brain matter that gives rise to consciousness? What we're looking for is the neuronal correlates of consciousness, aka NCC. For example, what processes must start in your brain for you to feel a headache? Do some special consciousness neurons need to be activated? If so, where are they located? Some experts argue that consciousness might arise from a particular type of information processing. In this case, consciousness emerges when incoming sensory information is broadcast globally to multiple cognitive systems of the body. They then process these data to speak, store, or call up a memory or perform an action. But since our storage space is quite limited, we can only perceive a small amount of information at any given moment. The network of neurons broadcasting these messages is thought to be located in the frontal and parietal lobes of the brain. Once the data are globally available, the information becomes conscious. The person is now aware of it. Modern machines haven't got to this level yet, but some experts believe that it's just a matter of time and computers of the future will be conscious. Another theory about consciousness is called integrated information theory. Its main idea is that each experience has certain properties and exists only for the subject as its owner. It's also structured and specific, like a frame in a movie. That's why an experience can't be separated into parts. Otherwise, it'll cease to be what it is. Now I've got a question for you. Have you noticed the dots that kept appearing throughout the video? If so, can you say what color they were? Okay, another question. Are you sure that other viewers saw the same color? Yes? Then let me tell you a story about the games our mind can play. There is a hypothetical concept known as the inverted spectrum. This concept refers to the philosophy of color, and its main idea is that two people might share the same color vocabulary, but their perception of the colors they see will be totally different. In other words, it's when someone experiences red objects like you experience green ones. Let's imagine how it could be if we applied this idea to our reality. Let's say you've been operated by a surgeon who accidentally messed up some connections between neurons in your visual system. These changes have led to an unexpected result. Those neurons that used to fire while seeing red objects now react to green objects, and vice versa. No wonder that after awakening from the operation, you find the world to be a very strange place. Your lawn, trees, and plants in your garden look red or purplish. The flamingo statues are now lime green, and the hue of cherry blossom resembles the color of the sea. These changes in your experiences are bound to get reflected in your behavior, mainly in your verbal reports. There will definitely be some straightforward evidence that an inversion has happened. Or let's say you underwent the same operation at birth, and you learn to apply color vocabulary to things with anomalous looks. But to you, these looks are not anomalous. so you use color vocabulary in exactly the same circumstances as all other people, but you see the world differently.
Despite all our differences, we share one thing in common. That's right, we all feel alive and actively perceive the present in this very moment. But here's the catch, my friends. This feeling of right now is in fact a little delayed. It takes about half a second for our brains to translate information into our consciences. If you think about it, technically, the future is already done for, but we're just not realizing this in due course. And that's not all. Our different senses pick up information each at their own pace, which means our brains have to drag some of them to give us a seamless sense of the present. It's like our brains are trying to stitch together a Frankenstein monster of sensory information in real time and make it look pretty. But here's where things get really wild. Researchers have found that they can mess with this perception. When that standard delay is removed, our brains get confused, and it gives us the impression that the effect happened before the action that triggered it. It's like you'd perceive the doorbell sound, but before you'd actually push the button. Weird, right? Why are our brains so easily fooled? Well, it's because our conscious minds have a lot of work to do. We have to translate the world around us, think about what might happen in the near future, and figure out what to do next. All of that takes time, which is not great when you're facing fast-moving danger. Imagine a dangerous wild animal jumps out at you. If you have to consciously think about how to react, you're done for. Luckily, our brains have emergency response kits that kick in when we need them most. The startle reflex is the fastest response triggered by a noise or sudden movement. Within 5 milliseconds, a lot of muscles are triggered into reacting, and you're already on the move before you know it. If we have a few more milliseconds, our brains can act in a more interesting way. The amygdala, our brain's first stop shop for processing emotions, takes about 12 milliseconds to process a threat. It's not super sophisticated, but it can easily detect danger. In fact, some of our best actions are done without conscious decision-making. Anything we do in less than half a second, like hitting a ball or catching someone's glance, is done automatically. So, while our conscious minds are great for long-term strategy, some of our best actions are accomplished without it. But let's get down to the real question. Thoughts can vary. Sure, we all know that because we've lived it. Making a difficult career or parenting choice takes a lot more thinking than choosing what to top your ice cream with. But did you ever wonder what the speed of thought is? I mean, do we need a Ferrari to keep up with our brains, or can we simply stick to a bicycle? Well, some scientists have tackled this tricky question by measuring how quickly we become aware of the information we gather through our senses. Apparently, we can detect stimuli that lasts as little as 50 milliseconds. That's about 1/20th of a second in case you're counting. Now, if we're talking about sensing and responding, let's use the sprinter reacting to the starting noise as a benchmark. That's lightning fast, taking only about 150 milliseconds. However, the speed of our nerve pathways can put a damper on our speedy thoughts. Back in the day, scientists estimated that it took 115 feet per second for information to travel down our nerves. But thanks to modern research, we now know that some well-insulated nerves can move at up to a whopping 394 feet per second. That's comparable to a bunch of the world's fastest cars in the world, like an Aston Martin or a McLaren. When you put it that way, the speed of thought is pretty quick. But don't worry, you don't have to train like an Olympian to keep up with your own brain. You might have even stopped to think about how many thoughts you have in a day. That question counts as a thought too, you know. Spoiler alert, it's more than you think. From the moment you wake up to the moment you fall asleep, and maybe even after that, your brain is constantly churning out thoughts. Some of these thoughts might be simple, like, I need to do laundry, or I should call my mom. Others might be more complex, like, what's the meaning of life? Or how do we love? Believe it or not, a study conducted in 2020 found out that an average person has over 6,000 thoughts per day. That's a lot of thinking. The study used brain scans to track when new thoughts began while participants were either resting or watching a movie. But not all thoughts are created equal. Some thoughts can make us feel happy and excited, while others can bring us down and cause us to worry. For most people, those negative thoughts can be hard to shake. Also, did you know that your personality can affect how many thoughts you have? People who are a bit more on the jittery side tend to have more thoughts than those who are calmer. But don't worry, having a noisy brain doesn't automatically mean there's something wrong with you. Sometimes our brains can even produce intrusive thoughts that are disturbing or upsetting. While it's natural to have these kinds of thoughts occasionally, if they're happening frequently and disrupting your daily routine, it might be worth talking to a professional. So, where do all these thoughts come from? Your brain's nerve cells or neurons are responsible for communicating with other cells by generating neurotransmitters. This sets off a chain reaction of firing neurons, which then creates thoughts. But what if you want to change your thoughts? It's possible. Techniques like mindfulness and working with a trained specialist can help you address unwanted thoughts and give you a more relaxed state of mind. Our brains are somewhat similar to the muscles that help us move around. We can train it to make our lives better. To an extent, that is. At the end of the day, it's not the number of thoughts that matters, but how they affect you and what comes out of them. Speaking of weird stuff brains can do, some mind-blowing news just hit the scientific community. Researchers have discovered some weird brainwaves in octopuses. Yes, you heard that right. These 8-armed wonders feature a type of brainwave we've never stumbled upon in the animal kingdom. Now, before you go imagining little octopuses wearing tiny shower caps with electrodes sticking out, let me tell you how this discovery was made. Scientists surgically attached electrodes to octopuses' brains and were able to get a glimpse into their thought processes. The amazing project captured the first ever brain recordings of octopuses that can move around as they please, and the results are mind-bending. The researchers discovered that some of the brainwave patterns are much like some found in the human memory center. This suggests that convergent evolution may be at play here. What does convergent evolution mean, you might ask? It's when two different animals end up having the same trait, even though they don't share a recent common ancestor. Another similar example of convergent evolution is that of dolphins and bats. They both use sound to figure out where they are, but their environment couldn't be more different. Octopuses have been considered fascinating by scientists and non-scientists alike. From their remarkable memories to their ability to camouflage themselves, these creatures are nothing short of incredible. They've been known to use objects to solve problems, and they even dream. Yeah, you heard that right. The color ripples that we can see across their skin as they sleep can show us that they may be dreaming too. However, octopuses are notoriously difficult to study. They can touch every part of their body with those long arms, which means they may have no problem removing whatever tracking objects scientists might have placed on them.
The distance between your outstretched arms is your height. You renew your skeleton every 10 years. Whoop, time to renew. You lose around 100 hairs every day, and that's totally normal. Humans are the only creatures who sleep on their backs for a long time. Koalas, like humans, have their own unique fingerprints. In a lifetime, the average person will walk the equivalent of 3 times around the world. A person can have from 250 to over 1,000 hairs in each eyebrow. Your eyebrows also have a lifespan, about 4 months for all the hairs to fall out and be replaced by new ones. Thank goodness. Your eyes are the only organ that doesn't grow with age. Human DNA is 96% similar to a chimpanzee, 90% similar to a cat, 70% to a slug, and 50% to a banana. That has appeal. You share 99.9% of your DNA with any random person on the planet. Your heart is the size of your fist. Your brain, 2 clenched fists. When you listen to music, your heartbeat syncs with its rhythm. You can't swallow and breathe at the same time. Trust me on that one. There are as many nerve cells in your brain as there are stars in our galaxy, about 100 billion. The popular belief that people only use 10% of their brain power is nothing but a myth. Even when you're resting or sleeping, more than a tenth of your brain is working. You're more likely to get attracted to a person who thinks and looks the same as you. The belief that opposites attract isn't true. Your nose and ears are the only parts of your body that never stop growing. The human brain generates enough electricity to power a small light bulb. If your eye was a digital camera, it would have a resolution of 576 megapixels. Your tongue prints are also unique to you, but let's not lick the scanner. Scientists at the University of Pittsburgh found that blue and green-eyed people are less sensitive to pain than brown-eyed people. But lighter-colored eyes are more light-sensitive than dark ones. The microorganisms in the human body outnumber cells 10 to 1. About 6% of people can vibrate and rapidly shake their eyeballs back and forth. It doesn't mean something's not right with their eyes, it's just a unique trick they can perform. Good at parties, I suppose. Fun fact about bones. You know that your body is about 60% water, right? What's new here is that your bones are also in this too. About 25% of human bone mass is made up of water. Not all of your brain's regions are active all the time, but most work on this or that task 24/7. Every 2 minutes, people all over the world take more pictures than they did in the entire 19th century. However, there's nothing said about today's photos being any better. People are kind of programmed to return favors. This instinct probably developed when people needed to help one another to survive. Studies have proved that sneezing is your nose's way to reset. A sneeze reboots the cells that line the insides of your nose. They're called cilia. Sneezing is also one of the first defenses against bacteria and other, unwanted stuff. When the delicate nose lining gets tickled with a foreign substance, like pollen, dirt, or dust, it sends a signal to your brain. The brain informs your body it's time to sneeze. The part of your brain that's responsible for vision is actually in the back of your head. The right side of your brain controls the vision on the left side and vice versa. Okay, put down your phone and pay attention. Multitasking is actually impossible. Your brain only allows you to switch between different tasks really fast, but not to do them at the same time. Such context switching isn't ideal either. Studies show that, in this case, people make mistakes much more often. Plus, they need twice as long as usual to do things. So, focus. There is one exception, though. When you're engaged in some physical activity you've done many times before, you can simultaneously perform a mental task. That's why you can easily walk up the stairs or take a shower and think about problems at work. Now, food tastes better when someone else has made it. That's why a sandwich from a cafe looks more appetizing, even though you used the same ingredients. One study suggests it's because it takes time to make yourself a meal, so when you're ready to dig in, you don't feel all that excited. Your body contains enough blood vessels to wrap around the planet 2.5 times. You spend 4 months in each year asleep. In a lifetime, you rack up 26 years. Only 6 of those years will be spent dreaming. We forget 50% of a dream within 5 minutes of waking up. 10 minutes later, it's 90%. Each cell in your body contains 1.5 gigabytes of information. Do the math for your 100 trillion cells and see that you're one powerful walking computer. Your brain cools down when you yawn. Your ears work even when you're asleep, but your brain ignores the incoming information. The bumps on your tongue aren't taste buds. They're called papillae. Not all papillae contain taste buds, but those that do that have 1 to 5 in each. The atoms in your body are 99% empty, and yet you feel full after dinner. Now, how is that? The brain grows for the first 18 years of life and then gets 5% smaller every 10 years after the age of 40. Well, that explains a lot, don't you think? We spend 10% of our waking hours with our eyes closed just from blinking. The muscles that work your fingers are actually in your forearm. Your foot is the same length as your forearm. Same ratio with your thumb and nose. Your toenails grow 3 times slower than your fingernails. Your lungs aren't identical. The right one has 3 lobes and the left one has 2. Your hair grows faster when you're sleeping. The only thing that grows faster than hair is bone marrow. Your body releases enough heat in a half an hour to boil 2 quarts of water. Your brain uses 20% of the energy your body generates. Your body uses more energy to cool itself on hot days than to warm up when it's cold. People can go much longer without food than without sleep. Stomach acid can dissolve metal. It's so strong that the stomach has to create a new lining every 3 to 4 days. So, what's eating you? Your stomach. In terms of muscle, your tongue is like an elephant trunk and an octopus arm. That's just wrong. Your nails are made of the same stuff as a rhino's horn and a horse's hoof. And the rhino wants it back. We have nails to protect our fingertips. Without them, you wouldn't be able to grip things as well. You use 200 muscles just to take one step, and 50 muscles just to use chopsticks. You use only 2 fingers to play chopsticks. Most people speak about 125 words per minute. The brain can process 800 in the same time. Me, I can go 185 with wind gusts up to 250. Your skin completely renews itself every 27 days. Now, you can't tickle yourself. Your brain already knows of your intentions and prepares your body for it. Humans are the only species with an outline that separates the lips from the surrounding skin. Half the bones in your body are in your feet and hands. Come on, let's share, guys. Finally, cornflakes have more genes than people do. Your cereal has 32,000. You have 20,000. Your memory is affected by your body position. For example, you're much more likely to recall a situation where you waved to someone if you stand and wave again. Your brain has millions of neurons. They're all different, and the speed of the connection between them is different too. That's why you can recall some information faster than others. The brain itself, by the way, can't feel pain. It has no nerve endings of its own. People with red-colored hair are 1% of all people. 2% are natural blondes. Yeah, most people you see with these hair colors have dyed hair. Black is the most common hair color in the world. A human eye resembles a car engine. Both of them need liquid for good lubrication. The engine needs oil, and the eye needs tears. To make sure the eyes work right, tears are distributed all over them. That's why we blink more than 10,000 times a day.
We've never sneaked a peek beyond the edge of the observable universe. What lies there? If we managed to get there, would we find another universe? What if the universe we live in is just one of billions of trillions of other universes? I'm talking about the concept of a multiverse now. Look, there's this idea of parallel universes. Let's take one of them. It looks exactly the same as our universe, and still, some details differ. Maybe instead of becoming a doctor, you chose to start a music band there. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, we live in a bubble that is just one of many other bubbles, which I guess looks like bath foam. These bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories, which mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. You see, it's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can throw light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known multiverse theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded rapidly and exponentially. Indeed, cosmic inflation does explain lots of the properties of the universe we observe. For example, the distribution of galaxies. When this theory was suggested for the first time, it was perceived as a piece of science fiction. But it can indeed explain tons of interesting features of the world we live in. So with time, people started taking it seriously. Now, the theory states that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. Another theory, called the many worlds interpretation, claims that there might be multiple branching timelines, or alternative realities. And in each of those realities, our decisions play out differently, which also means very different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely all overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes. But who knows? Maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one of them to another. Unfortunately, so far, there's no solid evidence that multiverses exist. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, I've got one scary thought for you to consider. What if, at one point, you stopped existing in your home universe, the one you were born into? What if your consciousness was transported to a parallel universe, where you're now watching this video? Think of this. $13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east-west, north-south, and up-down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the fifth dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the Virgo galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are 2 possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter, which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space. But the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the 6th planet from it. Scientists made a pretty cool 3D map of our solar system, where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it. We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day, we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars, it's just an empty, endless desert. Venus, only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently. Or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of superliquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light-years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars' satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution, and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.
Hey, can you speak up? I just ate an entire pizza. That's because after eating a hearty meal, our hearing tends to be a bit less sharp. During digestion, most of our bloodstream is directed toward the stomach, which takes away a bit from all the other organs. So, next time you want to go listen to your favorite band at a live concert, make sure to eat a lighter meal to keep your ears pitch perfect. On top of our stomach and left kidney, we have a magical organ that can grow back if we remove a part of it. Our liver can regenerate itself by making new cells called hepatocytes. They begin to multiply once the liver is damaged. The seriousness of that damage defines if it can regenerate completely and the amount of time it takes to do so. Ever wondered what's worse for your body? No sleep or no food? Turns out the lack of sleep is more dangerous. That's because if you don't rest, your body becomes exposed to a lot more risks. After 24 hours without any shut-eye, you can start to have memory problems and find it difficult to concentrate. At just 17 hours without sleep, you start to feel tired and groggy, irritable, tense, and more emotional. I need a nap. Your pain receptors also become more sensitive, which means everything hurts a bit more than it should. Oh, and it also affects your hearing too. What? On the other hand, you can be well into your 24-hour period with no food before your body realizes you've stopped eating. In the first 8 hours, you just keep digesting the last meals you had. After those first hours, you start to use stored fats for energy. Not eating for more than 24 hours means that your body will start eating away at its own protein. which means you literally start to lose muscle. Rainwater isn't always safe to drink. It can sometimes hold harmful bacteria and viruses. Also, in heavily polluted locations, it may even meet other harmful materials. Some communities out there do depend solely on rainwater as their primary source of hydration. But does rainwater have any other health benefits? Not really, according to current studies. Some of those risky substances may be removed from rainwater if you boil it, but it's best to stick to the safer side and only drink water from sources that are 100% safe for human consumption. Now, we produce sweat, mostly to regulate our body temperature and for some added moisture, like the one we need in the palms of our hands for a better grip. But sweat doesn't just show up on our skin. It comes out of around 5 million pores on our bodies. We're literally stepping on a quarter of our bones each day. We have just over 200 bones in our body, but about a quarter of those are in a very small surprising area – our feet. Since we have 26 bones in each foot, we end up with literally 52 in both. Now, our eyes produce tears for many reasons, like protecting themselves from infection or clearing up debris, such as smoke and dust, or when your baby done you wrong. But the number of tears we produce is quite surprising, up to 30 gallons per year. That's almost enough to fill a bathtub. Wow, that is heartbreaking. Our blood pressure wakes up hours before we do. That's because in the morning, the body produces a bunch of hormones like adrenaline and noradrenaline. They help give us the energy boost we need during our morning hours, but they also increase our blood pressure, which is usually higher between 6 a.m. and noon. During the night, since we should technically sleep and perform no physical activity, our blood pressure drops down by up to 20%. Speaking of our vital fluid, our blood accounts for about 10% of our total body weight. We tend to think of our body weight as being mostly made up of muscles, fat stores, and bones. But there's a lot more to it. In a fit adult person, bones make up 15% of the total body weight. About 40 to 45% is left to muscles, about 15% to fat deposits, and the rest are stuff like skin, tendons, hair, and other yucky things. Let's see. That adds up to, 100%. Your lungs aren't twins, they're siblings. That's because they aren't the same size or shape. Your right lung is bigger and tends to weigh more, and your heart is to blame for it since your ticker tilts to the left a little bit. This creates a small indentation in the left lung called the cardiac impression, which is also what funny heart doctors do at comedy clubs. The right lung may be bigger, but it's a bit shorter since it needs to make room for the liver. Doesn't your house have a liver room? Many of your body measurements are quite symmetrical in surprising ways. If you were to stretch out both of your arms, your wingspan, and measure it, it should show how tall you are. Based on these similar measurements, specialists can even produce theories about what ancient humans used to look like. Looks like we've evolved to be increasingly symmetrical to appear more attractive and healthier to attract mates. More so, since we've evolved to also walk on two legs, our symmetrical features help us to move around with the least amount of energy because it creates balance. Now, humans aren't natural champions when it comes to the scent of smell, that's for sure. But our noses can pick up about 1 trillion different scents. Scientists are still performing research on this subject and believe the number may be even higher. Some dog breeds may be able to notice scents somewhere between 10,000 and 100,000 times better than we do, but turns out the best nose in the animal kingdom may be attributed to the elephant because of its staggering number and type of olfactory receptor genes, over 10,000, while humans and chimpanzees have less than 400. We tend to look at our pinkies as our most delicate fingers, but we do have more power in them than we think. Turns out that should our pinky finger be lost or affected, the overall strength of our grip may decrease by up to 33%. The liquid in our stomach, made of hydrochloric acid, potassium chloride, and sodium chloride, is way more powerful than any acidic food you can think of, like lemons, pineapples, or tomatoes. The pH of healthy stomach acid should be between 1 and 3, so if you think about it, it's just below that of battery acid. Our hair strands are strong too, so strong that research is performed on them to duplicate their resistance into human-made materials. A healthy head of hair should be able to withstand up to 26,000 pounds. It's due to a little protein in the hair strand called keratin, which you can also find in your nails and skin. Now, only about 1/3 of us humans have perfect vision. There are a lot more glasses and contacts out there than you'd think, making up about 66%. Apart from different eye conditions, our vision also gets worse with age. When we're born, our heads amount to 1/4 of our total length. By the time we reach 25, our head will only be 1/8 of it. That's because our heads won't change their size a lot as we grow older, as opposed to the rest of our body, mostly when it comes to the legs and torso. Our brains are these super powerful computers, and a single human brain cell can hold 5 times as much information as the entire Encyclopedia Britannica. Maybe you remember that. We've yet to pinpoint the exact amount of data it can support, but in electronic terms, the storage capacity of the brain is around 2,500 terabytes. For comparison, the National Archives of Britain, which keeps over 900 years of history, only takes up 70 terabytes. It's probably the reason our brains need the most amount of oxygen compared to other organs. About 20% of the total oxygen that enters the bloodstream, and that's despite the fact that it makes up only 2% of our body mass. Our normal activities, plus the effect of gravity, make the cartilage in our ankles, knees, hips, back, and neck slowly compress. Once you rest overnight, the cartilage goes back to normal. On average, you are somewhere around 0.4 inches taller in the morning than you are later at night. And that's why they call me Stretch. You're in the middle of the Sahara. You see a huge awning with a red target pattern. Its surface is so hot you could fry food on it. A drop of water is to hit the center of this target at the speed of light. Theoretically and technically, this experiment is impossible to conduct. But if it happens, then mysterious nothing awaits us. And each version of this nothing will be different. So we'll do 3 drops. Option 1. It's better to do it from a great height or space. You take off on a jetpack into the stratosphere. You have a bottle of water in your hand. You pour out 1 drop. Let's say it starts accelerating itself. In this case, even at a low speed, a drop of water will burn up in the protective layers of the atmosphere. In less than a second, the drop will turn to vapor. Let's say our planet had no such protection as the atmosphere. The air resistance would still get rid of the drop. The drop is flying down at a tremendous speed. The cold wind turns it into an icicle. The greater the drop velocity is, the stronger the air resistance is. The drop is moving faster and faster, soon reaching the speed of sound. Then, it just smashes into thousands of small particles. Under such conditions, the drop will never be able to reach the Earth at the speed of light. Nothing happens because nothing gets to the target. The next attempt involves changing the drop. Oxygen, carbon dioxide, ozone, and other gases in the atmosphere destroy any falling object. But what if the drop didn't meet all these obstacles? You change the internal structure of water chemically. So, you put your jetpack on again and grab a bottle of water. At the height of the Earth's orbit, you open it and pour out 1 drop. It accelerates and there's no resistance. It passes through the hottest layers of the atmosphere, but doesn't burn, passing the freezing temperature, but doesn't freeze up. It flies to the ground, developing the speed of light, and crashes again. But nothing happens. The drop got the properties of a light particle, a photon. It's only under such condition that it might develop the speed we need. No object with mass, be it a car, a house, a tree, an ant, a single air, a grain of sand, or a molecule, can reach the speed of light. Only light particles are capable of it since they don't have mass. An intangible drop falls into the center of the target, and again, nothing happens. The third option. Scientists found a way to accelerate a drop to the required speed. They also have to change the molecular composition of water, making it more resistant to high and low temperatures. To make the drop reach the speed of light without any damage, you need to place it in a perfect vacuum. No air resistance, no protective layers of the atmosphere. We leave only space and the water. For this purpose, scientists need to build a long pipe, In the center of the Sahara, around the same target, people create a scientific center. From here, the pipe should go up. Its height is approximately the distance to the International Space Station. That's 254 miles, which is about the height of 50 Everest mountains. You can't connect to the ISS itself as it's moving all the time. It revolves around the Earth, completing one revolution in 90 minutes. That's why astrophysicists and engineers should build a small station designed for one person. And this station should move parallel to a single point on the ground. The vacuum tube is made of solid stainless materials so that rain and high temperature couldn't destroy it. Inside, it's an alloy of titanium and graphene, the most durable metal on Earth. The pipe is built horizontally. Then, with the help of several helicopters and cables, it's placed in an upright position and attached to a small space station. The pipe is equipped with small pumps that pump the air out and block its flow inside. The water drop shouldn't touch the walls, so there's a special layer of gravity plates. They push the water away from the pipe's surface, using the power of magnetism and sound waves. You put on a jetpack and fly to the station with a bottle of upgraded durable water. Your hands are shaking with excitement. Your breathing sounds loud in the spacesuit. You open the bottle, tilt it slightly, and pour one drop into a special box. Inside this container, the drop gets charged with the energy needed to develop the speed of light. Now it's ready for the journey. You look at the box, close your eyes, and press the start button. The drop flies into the pipe at a great speed. From the powerful blast wave, the entire station is thrown to the side. The drop accelerates, and at this point, the pipe made of the strongest metals on Earth begins to melt like ice cream. There's so much energy in the water now that it would be enough to provide electricity to a small city. And now the drop reaches the speed of light, which is 186,000 miles per second. The pipe turns to dust. It doesn't matter whether the drop hits the ground or not, because there will be nothing. Literally, all material objects, cars, houses, fields, oceans, computers, planes, ships, flowers, trees, should I go on, will disappear. Intangible things, such as gas, air, radio waves, electromagnetic radiation, billions of terabytes of digital information, all this will also be gone. Boy, are you in trouble. Any sound, shouting, music, the phone ringing, will be impossible to create and hear. The light will disappear, and then there will be complete darkness. But let's rewind time and see exactly what happened right now. It won't work, though, because there's no time either. Imagine time as a stormy river that flows rapidly in one direction. Then this river falls into an endless pit and disappears completely. All this happened because a drop of water crashed into our planet at the speed of light. As soon as a drop begins to approach the needed speed, it loses its properties of water. It's now the most powerful and heaviest object in the universe. The energy that comes from it destroys everything for hundreds of thousands of miles. Concrete, ground, rocks, etc., 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 and on and on and on. Everything disappears. In the first second, it all gets shattered into millions of tiny pieces. Then these pieces are torn apart into millions of even smaller particles. The molecules burn up. Imagine a paper map of the world. If you wet it and tear it, it will turn into wet paper scraps. If you burn it, then part of the map will turn to ashes, and the other part will simply fly into the air in the form of smoke. The map will remain, but it will never look the same. But if you destroy the map's molecules, it's safe to say that the map never existed. There's no trace of its existence. The same thing happens to our planet. The energy coming from a drop of water makes the Earth never exist in space. And now the drop exceeds the speed of light. A black hole starts evolving. It expands and absorbs all the space debris. Then the Moon. Soon it will be the turn of Mars and all the other planets in our solar system. The black hole expands and increases the force of gravity inside it. Together with our planet, it absorbs light. It's getting closer and closer to the Sun. Our star splits into strips of light as if it had passed through a huge cosmic shredder. The Sun explodes and spits out an impossible amount of energy. It's believed that black holes appear after the explosion of stars. Right now, all the solar energy is being absorbed by our black hole. It's getting pitch black. The light from distant stars falls directly into the supermassive infinity. Meteorites flying within a radius of hundreds of thousands of miles around are also devoured into the unknown. There are many black holes in space, but only one of them was created by a small drop of water. The higher the speed of any object, the heavier it gets. Mass is the amount of energy that an object has. When water molecules reach the speed of light, their mass begins to grow, and there are no limits to this. It becomes infinite. An infinite mass forms a black hole. It absorbs everything, and nobody knows what's inside the black hole. All that remains is darkness and the unimaginable force of gravity. So I'm guessing here that we probably should not be doing this experiment, should we? How about we make a baking soda volcano instead?
You can only cut a diamond using another diamond. It's the hardest natural material on our planet. Between retrieving the stones from the earth and the finished products you see in jewelry stores, a diamond goes through a complex process. Before they cut it, people need to consider which shape is best for the stone, so they don't throw too much of it away. One town in Norway, located north of the Arctic Circle, wants to become the first time-free zone in the world. The sun doesn't go down there at all between May 18th and July 26th. The locals don't want to follow the classic concept of time to get the most out of their 24 hours. Since they have constant daylight, they can't just act like the rest of the world. You can sometimes see people playing soccer in the middle of the night there, or mowing their lawns and painting their houses at 2 a.m. The Leaning Tower of Pisa is tilted because the soil under the building's surface is really soft. This was probably frustrating for the people who constructed it, but they eventually figured out the soft soil is part of the reason why the tower is safer from earthquakes. Because of the softness of the soil and the tower's stiffness and height, the tower doesn't resonate with earthquake vibrations. So the reason the tower is tilted is exactly why it's still standing, even in such an unusual position. You don't actually see pitch black in a pitch black room. It's a specific phenomenon, where you see dark light, or as people also refer to it, brain gray. It's a dark gray background many people see in the absence of light, and some even call it visual noise, since it's like an ever-changing field of small black and white dots. Watermelon is definitely one of the most refreshing and hydrating fruits, especially during hot summer days. But if you try some watermelon-flavored candies like gummy or hard candies, they're usually either mouth-puckeringly sour or very, very sweet. They aren't at all like the actual watermelon. It's basically impossible to replicate the great taste in the overly acidic-tasting watermelon candy. That's because its main chemical compounds are rare, and watermelon flavoring uses blends of cheap synthetic artificial flavors. Making high-quality realistic flavoring for candies and juices is possible, but would cost businesses a lot. Some people love the fake watermelon flavor, but most stick to their perception of how that fruity taste should be, and are not fans of it. Why is there an expiration date on a water bottle? Of course, water doesn't go bad, just like salt or sugar. But even though water doesn't go bad, the plastic bottle does. When it starts expiring, it leaches chemicals into the water. It won't make the water toxic, but it can change its taste, so you might not get the mountain spring fresh water you expected. Another reason for the expiration date on bottled water is there's a rule all consumable food products, including water, need to have an expiration date. Also, many companies that produce these bottles use the same machines for bottling sodas and some other beverages, and these do expire. So it's way easier to just put a stamp on all bottles, whether necessary or not, than to buy new special machines just for bottles of water. How come identical twins don't have identical fingerprints? The pattern of ridges on your fingers is unique and stays the same throughout your whole life, which is why fingerprints are a valid feature when it comes to identification. Two people could be sharing identical fingerprints, but the chances here are less than 1 in 64 billion. Identical twins have slightly different fingerprints because the patterns are affected by both environmental factors during prenatal development and genetics. Fingerprints are not just something that's unique to humans. Gorillas and chimpanzees have fine ridges on their fingertips too. They also seem to be unique to individuals, so we all probably inherited this from a common ancestor. Why does a green screen come in green and not some other color? When you film someone in front of a green screen, it's a technique known as chroma keying. The green color gets digitally filtered out so that you can replace it with any footage you want to add. If the subject you're filming is wearing something green, the background image fills that in as well. That's why it gives the impression the person you're filming has holes in them. And green is good for this since it resembles human skin tones the least. Why do you feel dizzy after spinning? There are hairs lining the sides of tiny tubes filled with fluids that are located in your inner ear. When you move your head, these hairs detect acceleration, which means a change in the speed of a certain object. If you spin for long enough, your brain can't deal with the constant turn signals from your ear, and the way it adjusts is to zero them out. At the moment you stop, your ears report zero turning correctly, but your brain is still in the mode where it actively cancels this out. It actually thinks that you have now started spinning in the opposite direction. So, how can ice skaters do all those amazing things on the ice and not feel dizzy? When doing a pirouette, they lock their eyes on a fixed point and keep it that way. They whip their head around really fast when they're not able to twist their neck further. Their spins are really fast, so they gradually train to overcome the feeling of dizziness and learn how to keep their eyes horizontal. That way, the view is spinning around one axis only. Neutron stars aren't that heavy, they're just really dense. So dense that just 1 teaspoon of a neutron star would weigh 1 billion tons. They are the densest and the smallest type of star we know of. Imagine squeezing 1.4 times the mass of our Sun into a sphere no bigger than 6 miles across. They're dense because of the way they form. The balance between an outward pressure process in its core and the gravitational force that tries to contact a star hold it together. When a star loses its supply of fuel, gravity wins, contracts the star, and eventually makes it collapse. When stars between 8 to 20 masses of the Sun collapse, this squeezes their core to be super dense. Their outer layers rebound and bam! Here's a supernova. It leaves behind an extremely dense neutron star. If a star has 20 solar masses or even more, the core doesn't collapse into a neutron star, but into a black hole instead. When you spend a day at the beach playing volleyball, swimming, or doing some other physical activities, you expect to be exhausted. But even when you spend a whole day just chilling around, you'll probably end up just as sleepy. Your body still gets very tired because it's doing a lot, even though you can't see it. First, it's always working to maintain your internal temperature. When it's hot outside, it requires way more effort, and your body cools off in a way it dilates your blood vessels. This boosts blood flow and helps your blood get closer to your skin. Over there, it can offload excess heat. That's also why some people blush when they're hot. You sweat more when it's hot outside, again, to cool down. And your metabolic and heart rate both increase, so you lose a lot of energy even when you're just lounging around at the beach. Why do animals have differently shaped pupils? The pupil is a hole in the iris of your eye that lets light pass through the retina. The iris muscles change the size of the pupil, which affects the amount of light that passes through. Because our muscles are placed in a ring that contracts equally towards the center, our pupils are round. This brings certain benefits. It provides consistent focus over the whole field of view. But circular pupils are unable to constrict as tightly as some other shapes of pupils. Animals that hunt or are prey to bigger animals evolve to have big, sensitive eyes at night. Bright daylight is just overwhelming for them. That's why they have an extra set of muscles that pull the pupil into a narrow slit shape in daily light. Predatory animals have vertical slit pupils, like many snakes and cats. Such pupils help them to have sharper focus across the horizontal field of view and determine better how far their prey actually is. Animals with horizontal slit pupils like sheep and horses don't have sharp focus at the right and left edges, but they have wider peripheral vision. That way, they can spot predators coming after them a lot better. You wake up with a start, open your eyes and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual: blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the Red Planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars. You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear: you're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The Sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid, large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. It would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings.
Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be two different scenarios. The first is the destruction of both planets, and the second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the Sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. Two massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the two planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the Sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the Sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the Sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles, or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe. All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly, and is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis. You look out the window and see the trees moving uncontrollably. The winds are so powerful, they're practically tearing down anything in the street. There are also tons of water raining down on you. You're driving as fast as you can, but suddenly your car stops. You've heard the terms typhoon, cyclone, and hurricane, but you most likely don't know how they're different. The official scientific term for all three of them is a tropical storm. While they're practically the same thing, and they form the same way, they're different depending on where they occur. Hurricanes are the ones that form over the Atlantic Ocean or the Eastern Pacific Ocean. Tropical cyclones act as giant engine turbines powered by warm, moist air and form only over warm bodies of ocean water near the equator. The warm and moist air surrounding the ocean rises and leaves low-pressure air close to the surface. In turn, the air below becomes moist and warm and also rises. The cycle goes on, with warm air pushing up and squeezing the low pressure near the surface, only to rise as warm, moist air. When the warm, moist air cools off, it forms clouds. These clouds create the tropical storms we all fear. The storms spin the same way as the Earth is rotating. So, storms to the south of the equator rotate clockwise, and storms north of the equator spin counterclockwise. The eye of the storm happens when the storm spins so fast that it actually becomes visibly clear in the center with low air pressure. But you'd have to look at it from above, which is super risky. Tropical storms normally move at around 39 miles per hour. Tropical cyclones are way faster, around 74 miles per hour. They're also known as hurricanes. If you're standing at the tip of the North or South Pole, the Earth's rotation will appear to stand still, even though the rest of the Earth is experiencing day and night like everyone else. In the poles, you have really long nights and days that last for months. Over at the equator, time moves along with the distance around the planet, which is around 25,000 miles long. The Coriolis effect makes wind patterns traveling long distances around Earth appear to move in a curve rather than a straight line. And because of the planet's unique shape, the speeds are different. It affects the Coriolis force and hurricanes as well. Because there's no curving of the object's path as measured relative to Earth's surface at the equator, the Coriolis force equals 0. A hurricane starter pack includes deep, warm ocean water. It all happens in the moist middle layers of the atmosphere, with a chilly atmosphere on top. It also takes some low wind and some surface disturbance. And it can stretch around 300 miles away from a large body of water where the center of a large hurricane is. The good thing is that hurricanes get weaker when they hit the land, because the warm water in the middle of the ocean isn't giving it the juice it needs to stay pumped. But it'll still carry a sustainable amount of damage with the strong winds and rain. In 1900, one of the biggest hurricanes struck near Central America and in the Gulf of Mexico. It then went as far as Florida and Texas, and is considered to be the most devastating hurricane in the United States' history. They first detected it on August 27th, and it lasted for many days. By the time it reached the Texas coast, the storm had turned into a Category 4 hurricane. Hurricanes are categorized on wind speed and intensity, using something called a Saffir-Simpson scale. There are 5 different categories from 1 to 5, with 1 being the weakest and 5 being the strongest. A Category 1 storm has winds moving at between 74 to 95 miles per hour. You can expect some trees to be uprooted and mobile homes destroyed. It can take out some home exterior and cause major power outages. Category 5 hurricanes speed up to over 155 miles per hour and leave nothing in their path. They can even wipe out some buildings right off their foundation. And because the winds are faster, there is more damage around its radius. Another thing to expect is lots and lots of flooding. The people of Galveston had less than 4 days to prepare for the arriving storm that even stretched out to Oklahoma and Kansas with 20-foot flash floods. The Great Hurricane then made its way to the Great Plains and turned towards the Great Lakes, New England, and reached southeastern Canada. The storm was so bad that more than 3,600 homes were damaged, even though they were sturdy enough to withstand the storm. Given the population numbers back then, it was equivalent to hundreds of thousands of houses destroyed, if not millions. The total property damage was around $30 million then, which would be a lot more now because of inflation. After the devastating storm, the people of Galveston built a 3.5-mile seawall and raised the whole city level by as much as 16 feet. Eventually, they raised the seawalls to 10 miles, just in case. If a storm like the one in Galveston struck in modern times, there wouldn't be enough places for everyone to hide. The population has increased significantly all over the areas where the storm struck back in 1900. So, imagine yourself sitting in your car and getting the breaking news. It says a storm has just hit the Gulf of Mexico and east of it near Cuba. No biggie, since you're all the way in Texas. So you drive back home. There's plenty of people at gas stations and in supermarkets. The news now states that the storm will likely gain momentum and strike right where you live. Okay, now it's time to panic. You want to get some stuff to prepare for the incoming storm, but all the shelves are empty by now. Everyone is pushing and shoving like at a rock concert. You grab whatever you can find and make your way back to your car. You're lucky enough to purchase some extra gallons of gasoline, just in case. You drive from supermarket to supermarket to try and get some stuff, but you're out of luck. Finally, you find a place that still has some essentials. You start stocking up your shopping cart when the local news urges everyone to evacuate. You only have a matter of hours to leave. But you left your dog at home! You rush against the traffic to get there. Your entire neighborhood is completely empty. You fetch your precious pooch and grab some important things before leaving. There's just a little time left, and you can already start to feel the winds picking up and the ocean nearby. The news tells you the hurricane has already struck Florida. You get in the car, but it won't start. Since you were driving so fast, you didn't realize that you emptied your gas. Good thing you got those extra gas cans on the way. With half a tank, you can get out of your city and into a safe place where everyone is going. The winds are getting stronger. There's no way you're going to outrun this storm. There's no one in sight since they all left early. It starts raining heavily. You can see some trees swaying like crazy. Finally, you find something that looks like a large shelter. You reach it to find out that it's just an abandoned mall. And then, the worst happens. You realize you've been going in the wrong direction all this time. You get out of the car for a bit to stretch out and see which road to take. The winds are so strong that you go back to the car only to find out that your dog ran off. You can't find her anywhere. You drive around and call out her name, but she doesn't respond. You see her standing behind some bushes barking. You run down to her and discover that she has found a cool underground abandoned shelter. The winds have now reached a dangerous point where you can't drive anymore. You gather your stuff and head down. It's complete with everything and even has a bed. You can hear the winds and rain above you, but you're snuggled up with your dog. The next day, you get up and see that your car has been tossed over to another road, and there's not a single tree in sight. But hey, you can at least be happy you survived one of the strongest storms in the world.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Batygin have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry. They say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there. Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans, its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface. But if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214. An unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it. But it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler, Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? All right, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light-years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than -360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP-76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP-76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways, so it's probably not the place where you'd like to spend your vacation. The universe is three-dimensional. Okay. No, the universe is four-dimensional. 3 dimensions for space and 1 for time. Okay, duh, what are you talking about? The universe has 9 dimensions. Okay. Come on, guys. The universe is flat. Wait, what? However strange it may sound, all these statements are kinda true. How come? The theory of general relativity allows for the universe to take one of 3 forms. It can be flat, like a sheet of paper. It can be completely closed, like a sphere. Or it can be shaped like a horse's saddle. It's very important to figure out the shape of the universe. This way, we can learn about its past and future. It can answer crucial questions. Is the universe going to expand forever, or will it eventually collapse? Is it finite or infinite? Here, we need to consider 2 factors: the density of the universe and the rate of its expansion. Now, hear me out. About 68% of the universe is dark energy, 27% is dark matter, and the remainder is normal matter. That's what stars, planets, and our bodies are made of. And when we speak about the universe's density, we mean the amount of matter packed into a given volume of space. And the density of the universe is so great that its gravity is more powerful than the force of its expansion. Then the universe will curl into a sphere. This is what we call the closed model. The coolest thing about such a universe? Even though it is finite, it has no bounds. However paradoxical it may sound, if you found yourself in this universe, you would travel its space forever without falling over an edge or hitting a wall. But if the density of the universe was low, it would be unable to stop its expansion. In this case, space will warp in the opposite direction, creating an open universe shaped like a saddle. But the most popular theory, and the most bizarre-sounding one, is that the universe is flat. It might be possible if its density is just right, and it expands in every direction without curving negatively or positively. Scientists claim that it's the most plausible scenario, by the way. So, if you're disappointed by our planet's roundness, the flat universe might come as some consolation. But what does a flat universe mean? I mean, our 3D world seems very real. Can it be just an illusion? Nah. The flatness of the universe isn't that 2-dimensional flatness you might be imagining right now. To help you understand this concept better, I'll tell you this. In a flat universe, 2 rockets flying next to each other will always remain parallel. In a closed universe, their paths will diverge, and they will follow the curvature of space and eventually make a loop and meet where they started. And in an open universe, these rockets will separate and never come across each other again. Of course, it'll take a lot of time to prove that the universe is indeed flat. But so far, astronomers don't have even the slightest reason to doubt this theory. All the data they have is consistent with this flatness. For example, the imprints left on galaxies from sound waves that occurred right after the Big Bang also support this theory. In other words, right now, scientists agree that the universe we live in is like a 3-dimensional sheet of paper. Good luck trying to imagine this. But if this idea is wrong and the universe is actually curved, it must be ginormous, because those 93 billion light-years we can observe aren't a large enough portion to let us see even a tiny curvature. So, it might be wrong to say the universe is flat. It's probably better to announce that the little bit of the universe we see is flat.
The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light-years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is. Electronic satellites suddenly go out of control. There are voltage surges across the globe. In some places, there's a complete blackout. Scientists have little data on this incredible solar behavior, so we're still unable to accurately predict how or when exactly the next geomagnetic storm will happen. One such event took place back in July 2012, but thankfully it missed us. Not by far, though, by a mere 9 days. Just to give you a glimpse of what nearly happened, I need to explain some astronomical basics. A solar storm is a series of effects we feel here on Earth after certain events occur on the Sun. Our star is nothing more than a huge ball of molten gases that are constantly moving around, so these events happen more often than you'd think. For a solar storm to begin, our Sun needs to emit bursts of energy. They're in the form of solar flares and coronal mass ejections. These two phenomena send electrical charges and waves of magnetic fields toward the Earth at an astonishing speed of about 3 million miles per hour. When these solar storms reach our planet, we can see northern lights display in locations close to the Arctic Circle. But they can also mess up satellites or other types of electronic communications. Some of these solar storms can be dangerous, and back in 2012, we came close to experiencing a very powerful one that could have had a serious outcome. The most powerful in as much as 150-plus years, based on research done by astronomers. But how did we manage to escape it? Did we have something to do with it, or was it just a pure coincidence? What we do know is that one of those coronal mass ejections did hit the Earth's orbit in late July 2012. Our planet had already left that specific location as it was on its scheduled trajectory around the Sun. So you might be asking yourself at this point, what if it didn't miss us? Turns out these intense solar storms are dangerous to all sorts of technological objects. Given we are now literally surrounded by electric objects, from our phones to our cars, try to imagine what would happen if they all stopped working all of a sudden. And here's how they work. Solar storms start with an explosion, or a solar flare. Then X-rays and UV radiation travel to our Earth at the speed of light. Some of the side effects? Well, they can include radio blackouts and GPS navigation errors. The effects can continue as minutes, or at times hours later, energetic particles reach our atmosphere. They move only a bit slower than the speed of light, but they can electrically shock the Earth's satellites and damage their components. Lastly, about a day later, clouds of magnetized plasma reach us as well. They can cause huge power blackouts, more or less paralyzing everything with an electrical plug. We might not even be able to flush our toilets, since most water supplies in cities use electric pumps these days. The effects of these geomagnetic storms would be different around the world, though. Solar storms are curious by themselves, but why do they affect some locations on Earth more than others? Based on recent research, geology has a lot to do with it. But I need to take you back a bit to paint you the bigger picture. Buckle up, because we're taking a trip in the time machine to a time when the moon didn't even exist yet. 4.6 billion years ago, our solar system looked a lot different than it does now, and that's putting it lightly. Hundreds of new planets began to form around the new sun. Planets like our own Earth, Venus, or Mars were still hurtling around the cosmos. Back in the 1970s, an astronomer named Donald R. Davis developed a theory that said the moon was born when another planet hit a newly formed Earth about 4.5 billion years ago. He also indicated that it might have been the size of Mars and later named this planet Theia. It's difficult to imagine what that impact might have looked like, even with the equipment we have these days. The astronomers suggested the giant impact hypothesis, trying to piece together this mystery. After running into our planet, the outer rocky layers of both Earth and Theia were projected into a circle of cosmic matter. Out of this debris, what we now know as the Moon was born. The Earth's core has apparently consumed Theia's iron core, that is, if it had any. Our planet also got into the position it occupies today. This way, it became more susceptible to geomagnetic storms. Back then, there was little to no information as to what might have happened to Theia, apart from giving us our only natural satellite. It took several years for a series of scientists to come up with an exciting new idea that revolutionized what we knew about our planet. What was left out of Theia is hiding under two continent-sized layers of rock deep within our planet. This theory is also one of the only explanations for why the moon is so dry and doesn't have much of an iron core. But why is geology so important when it comes to geomagnetic storms? Well, that's because recent data revealed that the type of rocks below your feet can affect how well your city adapts after powerful geomagnetic storms. Some types of rock, like sedimentary rocks for example, generally have more space filled with water, which makes them electrically conductive. Other types of rocks are denser and have more resistance when it comes to electricity. Whenever such a storm happens, people living in the New England highlands may have a higher risk of experiencing major disruptions. At the same time, those in the mid-Atlantic coastal plain have less to worry about, simply due to what's hidden beneath their cities. How did we know how scary these storms are? Well, this wasn't the first time it happened. Solar storms have dazzled the astronomer community for many years now. The most iconic event of this magnitude was the Carrington event, which happened way back in September 1859. It gave us a sneak peek of what the power of the Sun is, to say the least. They named it after an English astronomer, Richard Carrington, who witnessed the solar flares himself. The power of that solar storm was something humans had never experienced before. The strong geomagnetic storm caused northern lights as far down south as the territory of Hawaii. On the morning of September 1, 1859, Richard Carrington made his way into his private observatory, located outside of London. He opened the observatory dome to have a complete view of the sky and directed his telescope to the location of the Sun. He saw a bunch of huge dark spots that gleamed on the surface of our star. Shortly enough, Carrington noticed two enigmatic areas, intensely bright and full of white light bursting out from the sunspots. They disappeared 5 minutes later, but the effects carried on all across the Earth's surface. At first, later in the night, telegraph communications all around the world started to malfunction. Flashes of light started to burst from telegraph machines, disturbing the operators and even setting papers on fire. Brightly colored auroras started to appear in the nighttime skies all over the world, making confused birds chirp at night. Some people even began their daily activities, since they mistakenly thought the day had already begun. These days, our planet is laced with a mega information web, so the impact of such a solar storm would be even messier. Back in the 1800s, the telegraph system was just starting out, but this Victorian internet was an important way of sending news and private messages. Even in the United States, telegraph operators had noticed local interruptions because of thunderstorms and northern lights before. But the Carrington event and its effects were something they had never seen before. A lot of telegraph lines in North America became useless. One telegraph manager based in Pittsburgh even recalled that the currents flowing through the wires were so strong their platinum contacts were in danger of melting. Another example was that of a telegraph operator located in Washington, D.C., named Frederick W. Royce, who was hurt as his forehead touched a ground wire. Samples taken from the Earth's icy locations tell us that the Carrington effect was twice as big as any other solar storm experienced in the last 500 years. It's very difficult to imagine what the impact of a storm of that magnitude might be today. But based on a 2008 report drafted by the National Academy of Sciences, it might cost us between $1 trillion and $2 trillion in damages. There are things we can do individually to help reduce the amount of damage, though, like buying a generator or installing a backup energy supply. This can be either a solar panel or a wind turbine. More so, we can equip our houses with surge protectors that connect to our electrical panels and can save us from lightning and other power surges. The simplest solution of them all? Just unplug all the devices you're not using at any particular moment. If they aren't